It is the first mission devoted to mapping the moon's gravity field. NASA's GRAIL-B spacecraft has joined its twin, GRAIL-A, with both circling the moon now.
For centuries, the moon was written off as a dead rock, silent, predictable. But new data ripped that idea apart. NASA's GRAIL mission uncovered something no one saw coming.
In 2012, NASA's GRAIL mission crashed into the moon. GRAIL stands for Gravity Recovery and Interior Laboratory, and the mission consisted of two twin spacecraft named Ebb and Flow that are about the size of a washer and dryer.
The moon is flexing, quaking, and even hiding a radioactive heart. Ryan Park and his team at JPL spent years checking the numbers, convinced it had to be a mistake. It wasn't. And when you hear what's really happening up there, you'll be shocked at how wrong we were about our closest neighbor. The moon's hidden flex. Back in late 2011, NASA launched two spacecraft called Ebb and Flow. These weren't giant machines, closer in size to your average washing machine.
And the mission consisted of two twin spacecraft named Ebb and Flow that are about the size of a washer and dryer.
But they packed serious tech. For an entire year, they orbited the moon, tracing its gravity field. And they didn't miss a beat. We're talking detection levels smaller than the width of a human hair. As they passed over craters, mountains, and lava plains, gravitational tugs made them speed up or slow down just a fraction. That was enough to trigger the instruments. What came back was shocking. The moon isn't a frozen statue. It's stretching and compressing every time it circles Earth. Invisible forces pulling at it like a rubber band, causing surface rises and dips of several feet. And this isn't ancient history. It's happening right now, with every orbit, every month. Ryan Park and his team at NASA's Jet Propulsion Lab couldn't believe the numbers. They ran the math again and again, hunting for mistakes. But the results kept screaming the same thing. The moon breathes, not in air, but in motion. And then came the deeper question.
Understanding how the moon has developed would really help us in understanding how the other planets in the inner part of the solar system, the rocky planets, have also developed.
If the moon is flexing, is it doing it evenly? That's where things get weird. Because when scientists looked closer, they saw a split. One side bends more than the other. One side gives, while the other holds firm. That raised a new mystery, and it started right where we've never been able to look, the moon's hidden face. A two-faced mystery. So the moon flexes. That alone shattered old ideas. But the twist, it doesn't flex the same way everywhere. The near side, the one we see from Earth, moves differently than the far side, the one that never faces us. And that raised one major question. Why does one half of the moon behave like it's alive, while the other stays frozen? This wasn't some minor detail. It was like discovering your neighbor had two completely different houses stuck together. One modern, flowing with heat, the other old, cold, and untouched. For centuries, nobody knew what the far side looked like. It wasn't until the 1960s that spacecraft finally gave us a view. What they found was bizarre. The near side, the one we've stared at since the dawn of time, is smooth and dark in places, coated with volcanic plains called Maria. But flip over to the far side, it's a cratered, jagged mess. Rugged highlands, barely any Maria. 2% coverage compared to over 30% on the near side. It didn't even look like the same planet. Theories flew. Maybe Earth's gravity helped molten rock rise only on the side facing us. Maybe the far side's crust was thicker, locking everything in. But none of that fully added up, until Park's team dropped the GRAIL data. The gravity map showed something wild. The near side wasn't just shaped differently, it was moving more. Every tidal cycle, it flexed harder than the far side. That meant there was something deep down, buried inside the moon, that was making one half softer and the other more rigid. So now we weren't just dealing with a flexing moon, we were staring at a moon with two personalities. One volcanic, one untouched, one that bends under pressure and one that resists. And to figure out why, scientists had to dig beneath the surface, to a hidden heat source they didn't expect. The radioactive heart. When scientists followed the trail, they found the smoking gun, a cluster of radioactive elements heating the near side from the inside out. It wasn't the kind of radioactivity that glows green in the dark. This was the slow burn. Isotopes like uranium, thorium, and potassium, leftovers from the moon's violent birth, had piled up unevenly, and somehow, most of it ended up beneath the side that faces Earth. Over billions of years, those elements decayed, releasing steady heat like embers hidden in ash. That underground warmth kept the near side's mantle soft, allowing volcanic eruptions to spill out and paint those dark Maria across its surface. Meanwhile, the far side, without that internal fire, stayed stiff, scarred, and mostly untouched. This wasn't a coincidence. The radioactive hotspot helped explain why one half of the moon flexed more during tidal cycles. Every 27 days, Earth's gravity grabs the moon and gives it a tug. The warmer near side yields like dough. The colder far side barely budges. It also explained why volcanic activity lit up only one hemisphere. That internal heat was like a secret engine, running just beneath the crust. Not powerful enough to boil the whole moon, but just strong enough to reshape one side. And here's the kicker: that process hasn't stopped. Even now, those radioactive elements are still decaying, still producing heat, still softening the near side's mantle just enough to let it move. But to truly map what was happening beneath the dust, NASA had to go beyond heat maps. They needed something sharper, something that could measure movement on a microscopic scale. Precision unlocked. If the moon was hiding secrets under its crust, scientists needed tools that could see through the stone. That's where GRAIL went from good to legendary.
The two spacecraft, called Ebb and Flow, were commanded to deorbit and plummet into the surface of the moon.
Ebb and Flow weren't just orbiters, they were precision machines. Flying in tight formation, just 35 miles above the surface, they scanned the moon's gravity with mind-blowing accuracy. Their method? Microwave links measured tiny shifts in the distance between the two craft as they passed over different regions. If one sped up just slightly, due to a gravitational pull beneath it, the link picked it up. Over time, those measurements built a gravity map so sharp, it made Earth's own data look outdated. But getting clean data wasn't easy.
After mapping the moon's gravity for more than a year, NASA's GRAIL spacecraft have finally self-destructed.
The sun's radiation pushed on the spacecraft. The extreme temperature swings made parts expand and contract. Even distant planetary gravity had to be filtered out. Ryan Park's team ran millions of simulations, stripping out noise, locking in on the real signal. What they got wasn't just a map, it was a time-lapse of the moon flexing in real time. Each rise and fall, each tiny bulge and sag recorded and translated into data, and that level of precision didn't just unlock the moon. Scientists turned the same tools toward asteroid Vesta. That's where things got weird again. Unlike the moon, Vesta didn't show layers. No core, no mantle, no crust split. Just uniform rock, top to bottom, like someone had smashed it apart and stirred it back together. That changed how researchers thought about early solar system formation. Maybe these worlds didn't evolve smoothly. Maybe chaos ruled from the start, which led to a bigger question. If Earth's moon flexed with heat and Vesta didn't, what about other moons? Ones farther out, under more pressure, trapped in the grip of giants. Worlds under pressure. Once GRAIL proved how much we could learn from a flexing moon, scientists turned their attention to the real beasts, moons orbiting gas giants. First up, Jupiter's nightmare child, Io. Io is wild. Over 400 active volcanoes, some spewing lava hundreds of miles high. For years, scientists thought this chaos came from a global magma ocean sloshing beneath its crust. But recent data from NASA's Juno mission flipped the script. Instead of one big molten sea, Io's insides are a patchwork, pockets of magma trapped in solid rock, like bubbles of fire frozen in stone. It's still hot, still dangerous, but it's not what they expected. Turns out, even with Jupiter's massive gravity squeezing it like a stress ball, Io didn't melt cleanly. It fractured, heated unevenly. The same lesson GRAIL uncovered on the moon now echoed across the solar system. Flexing doesn't play fair. It creates quirks, imbalances, deep, invisible scars. And it didn't stop with Io. Saturn's icy moon Enceladus, famous for its water geysers, might also be flexing off balance. Europa, Jupiter's ocean world, could be shaped by uneven forces beneath its crust. Even Pluto, way out in the cold, revealed signs of internal complexity when spacecraft flew past in 2015. The more scientists looked, the clearer it became. No moon is just a rock. Every one of them is being bent, twisted, cracked, or heated in ways we barely understand. Some are hiding water, others are hiding magma. All of them are reacting to ancient forces still at play, and that brought everything full circle. Because if tidal stress could keep distant moons alive beneath the ice, what did that say about our own? A new view of the moon. By now, the story had flipped. GRAIL's discoveries forced scientists to rethink how worlds form.
GRAIL will be the first time that any space agency has attempted to fly two spacecraft independently to another solar system body.
The moon, with its radioactive near side and rigid far side, wasn't the neat product of a tidy impact. It was uneven from the start. Same with Vesta, expected to be layered like Earth, but turned out flat and mixed. The old models, where heavy stuff sank, layers formed, heat spread out, didn't match reality anymore. Instead, what scientists found was messier. Worlds formed fast, violently, and the scars are still written in their gravity fields. But this wasn't just academic. For NASA's Artemis program headed back to the moon, those gravity maps became critical. You can't land a spacecraft safely without knowing where the surface rises and dips. You can't build a base if the ground underneath flexes with every orbit. And those shallow moonquakes? They're real, and they're dangerous. At the same time, that hidden internal heat, it's an opportunity. If the moon still holds geothermal energy, future explorers might tap it for power. If gravity variations point to water ice or hidden metals, it could shape where humanity builds its first lunar colony. Suddenly, the moon wasn't just a relic. It was a resource. Every orbit, every flex, every strange vibration was telling us something. The moon is still changing, and it's still hiding secrets we haven't uncovered yet. So here's the big question. If the moon, our closest neighbor, was able to fool us for this long, what else is out there? The search for answers didn't stop with GRAIL, because just when scientists thought they'd seen it all, the moon hit back with something they didn't expect to feel. The moon's silent quakes. Right when scientists thought they had the moon's behavior mapped out, something deeper began to shake. Because buried in the data from the Apollo missions were signals, tremors, telling a new story. The moon was quaking. These weren't like Earth's tectonic jolts. The moon doesn't have plates shifting beneath the crust. These were different, more subtle, more eerie, and sometimes more powerful than anyone expected. The Apollo seismometers picked them up decades ago. Hundreds of quakes, some shallow, some deep, some so long-lasting they shook the lunar surface for over 10 minutes. The most mysterious? The shallow moonquakes. They hit near fault lines and boundaries between the moon's flexing near side and its stiffer far side, exactly where the GRAIL data showed pressure building up. For years, these quakes were brushed off. Just background noise.
A study published this year reanalyzed the decades-old data and found thousands of moonquakes.
But when scientists matched the seismic data to the gravity maps, a new picture formed. These were part of the same internal stress cycle that drives the moon's monthly flexing. Think about that. A body with no tectonic plates, no oceans, no weather systems, still manages to shake under its own internal tension. The moon is constantly pulled by Earth. That tidal tug, combined with radioactive heat beneath the surface, builds pressure. Eventually, something gives, and that's where it gets serious. Some of these shallow quakes reached magnitude 5 on the seismic scale, strong enough to damage structures, strong enough to threaten future lunar habitats. For Artemis astronauts planning long-term missions, that's a real risk. Lunar bases can't just be placed anywhere. They'll need to be built in quake-stable zones. And just when we start to grasp one hidden layer, another one stirs beneath it. The moon's magnetic ghosts. Seismic activity wasn't the only clue that the moon had a wilder past. There's something else, something that's still messing with compasses and instruments today. Magnetic scars. Here's the strange part. The moon doesn't have a global magnetic field anymore. No swirling molten core like Earth's. No magnetosphere to shield it. But scattered across its surface are these weird patches. Localized zones of magnetism strong enough to distort instruments. Scientists call them magnetic anomalies, ghost fields, and they've been baffling researchers ever since the Apollo astronauts brought home lunar rocks. Some of those samples were magnetized.
We knew it lost its magnetic field long ago, but astronomers just found that field lasted over 1 billion years longer than we thought.
But how? If there's no field now, what locked those signatures in? To get answers, researchers had to look way back. Billions of years ago, the moon might have had a molten core, hot enough, churning enough to generate a magnetic dynamo. That core didn't last. The heat faded, the dynamo shut down, but not before it left fingerprints in the crust. And then came the impact theory. Some anomalies appear near large craters. Scientists now believe that when giant asteroids slammed into the surface, they generated enough heat to locally supercharge the rock, magnetizing it while molten, just before cooling. But these ghost fields aren't just relics. They affect spacecraft, they mess with instruments, and they may hold deeper clues. Could these zones reveal where the moon's inner dynamo first started failing? Could they point to rich deposits of iron, nickel, or even radioactive materials? For future missions, those patches could either be hazards or assets. If understood correctly, they might protect sensitive electronics, or reveal resource-rich zones just beneath the surface. But even at the microscopic level, the moon's got one more trick. Something small, sharp, and electrically alive. The moon's strange dust. Even the moon's dust. Yeah, the fine gray stuff covering everything turns out to be far stranger than anyone expected.
The moon's environment is incredibly hostile, but some Earth microbes are famously resilient.
At first glance, it looks harmless, but ask the Apollo astronauts, they'll tell you otherwise. That dust clung to everything, scratched their visors, wore down equipment, even caused some of them to sneeze once they got back inside the lunar module. And it wasn't just annoying, it was aggressive. Why? Because lunar dust isn't like Earth's sand. It hasn't been weathered by wind or water. Every particle is jagged, sharp, and electrostatically charged. The sun's radiation hits the surface directly. No atmosphere to soften the blow. That charge builds up on dust grains, making them float, move, levitate. Astronauts reported seeing a strange haze along the horizon during lunar dusk. Scientists now think it was charged dust rising and falling, creating a kind of invisible storm just above the surface. That might sound minor, but the implications aren't. Dust that floats can get into machines, into joints, seals, air filters. It can damage rovers, short out electronics, and pose serious health risks if inhaled over time. For future missions, especially long-term ones, it's a problem that can't be ignored. But here's the twist. That dust might also be reacting to the same forces causing tidal flexing and magnetic anomalies. The moon's electric and magnetic environment is more dynamic than anyone guessed. Charged particles don't just sit still. They shift, dance, and interact with invisible fields shaped by internal heat and ancient scars. So the moon's surface isn't silent either. It's restless, even at the grain level. And underneath that shifting dust, there may still be something stirring, something deeper, a core that refuses to cool completely. Drop your thoughts in the comments, hit subscribe, and stay tuned, because the universe has only just started talking.